Good morning, everyone. Can you hear me? Good morning, everyone. Can you hear me? If you can hear me, can you please put it on the chat? And I see a good number of participants. Yes. Okay. And considering that this is the very first training for this academic year, how many of you have attended? I mean, is this the first year computer science program for you people? Super Teacher Computer Science program? How many of yours is the first year computer science program this year? Second year. Yes, Rashmi ma'am. Yes. Okay. There's a good number of first year teachers. Okay. Maybe I think others are also like this training will be more two-way training. It's not like where we just only share our experiences, right? So it would be good to just put your thoughts on the chat. Got it. I think there's a uh, decent number of people who are kind of teaching this program for the first year. So, considering that this is the first training for this academic year, I thought of balancing it in a way where for all the new teachers who are teaching this program for the very first time, we would do something similar to what we have done the last year. And also for the teachers who have taught for the whole academic year last year. So for them also, there's some parts of it. So we try to balance both aspects. So I think for the teachers who are teaching it for the second time, probably some of these is something that we have dealt with the last year. But I think it will be a quick recap. Let's get started. But before we get started, all this, I just want to quickly hear what is on your mind that you want to achieve by the end of this 2 hour training. So what is something that you're looking forward to? So what are we expecting by the end of this 2 hour training? What do you want to achieve so that you can, I think, what's the goal according to you? Anyone just put what do you want to achieve by the end of this 2 hours training? Okay. It would be good to hear more voices on the chat. I think that will be a lot helpful. Okay. Got it. Fine. Let's get started. So I think so this is the very first training for this academic year. We'll also have more trainings for the computer science in the coming months. So considering that this is the very first academic year training, so for all the new teachers, I think this program aims to give you a head start in actually ensuring that you get to implement this program well in your coming academic year. And for the teachers who have been teaching this for 1 year, right? Um, so for other teachers, I think it's a quick recap on what we have discussed last year. And also like in the part of this training session, we'll also discuss your experiences of how this last 1 year of teaching super teacher computer science program has gone, and what are your experiences and what changes. All of those different things is something that's also part of this particular training, right? So I think the goal is to empower teachers to deliver the engaging CS lessons. So in that, what do we want to achieve by the end of this 2 hour session? So in this 2 hour session, for all the teachers, even though you're starting your fresh academic year, how do we get our first super teacher class delivered the right way, as how we have thought through about the program, how we have done it. So how do we get that into actual action in the classroom? So that is what this whole training is all about, right? And before we get started, how many of you have completed the pre-test? So people who have done the pre-test, can you just put it in the chat? All those who have attended it, I mean, given the pre-test before attending this training. Okay. And if there is someone who's left, I'll just say, let's just take quick 2 minutes. There are not a lot of questions there. If you can help us with completing that test, that will be a lot helpful. Done, done. Okay, I think a lot of them have finished. And if there is someone, maybe just take another a minute or so, finish off the test so that we can focus on what's at hand. Okay, so I think before we get to the training, I think we need to have few things so that this will be more effective training, right? So of all the people who are currently there, do all of you have Super Teacher app access with Super Teacher Computer Science program content being able to access and all that? Is there anyone who doesn't have access? If it is so, please put it on the chat, please. Do all of you have your Super Teacher app? If so, please open your Super Teacher app for this training. Okay. Others as well, like one, if you don't have access, please keep me posted. If you have access, please open that. This will be quite useful in our current training program. Or do anyone need support in accessing the Super Teacher app? Okay, great. So I'm assuming that most of you have the Super Teacher app access. Then that's great. First, ensure that you have Super Teacher app. If it is on the mobile phone, then that's great. If it is not, then you can even open in your laptop. Just type Super Teacher app in. I mean, I'll just show you. You can just go to Google search, put Super Teacher app. You can just click on the second link, then just plug in your credentials. It will open the app, right? So even though if you don't have it on your mobile phone, that's okay. You can just open it on the web. Okay. And are there teachers who, I think Pavitra ma'am, okay. So are there teachers who have Super Teacher app but do not have computer science access? So maybe I'll just quickly show you for people who don't have computer science access, how can you enable it? So if you go to your Super Teacher app, so there's this small right icon at the top. You just click on this small right icon, click on teacher, then you have to go to your subject and then choose computer science. If you just click, there's no subject added, just click here, add a subject like just like this, add a subject, choose computer science, choose the grades that you're kind of teaching. So then you'll be able to access the content. Yeah. So if there are people who are kind of struggling, maybe just go click on your right icon at the top, choose teachers, then go to your subject, choose computer science. So for this, I mean, today's training will use grade 2 and grade 4 content. So maybe you can just try to access grade 2 or grade 4 if you have the access to those kind of grades. Okay. So the first thing, let's have our Super Teacher app access, be it on your mobile phone or it on your laptop or any device. So let's have that. Please add your computer science as a subject so that you can access the content over there. And also, it is great if you can have certain, pen, paper, notepad to just take quick notes. Or also, we do a lot of learning as a part of this. So I think it would be great if you have some quick means for making notes. It could be digital also. That's great, right? So if you're all sorted with this, just give me a thumbs up on the chat so that we can get started. Ensure that you have your Super Teacher app access. Make sure that you have access to the Super Teacher content. Then have some quick uh, means through which you can make some quick notes or something, right? Great. So let's get started. So So these are a couple of things that we want to do by the end of this session, right? One is, how do you deliver this hands-on experiential computer science lessons in your classroom? So that's the first thing. Like, how do you facilitate these kind of learning experiences in your classroom? Then coupled with how to use your Super Teacher app effectively so that you can deliver a great learning experience as how we have designed it, thinking that it's both teachers are comfortable teaching it and also kids are enjoying learning the way it is. Then the third thing is, what is there in your books and workbooks, content book and workbooks? How do you use them to your advantage in your classroom? So that is also something that we'll learn and also get a little bit of understanding for all the new teachers, like why is the program designed this way, and what is the goal with which the program was designed, so that you can ensure that when you're teaching it in the classroom, you have this at the back of your mind, and then ensure that we are kind of standing to the expectations of what the program envisions, right? So that is the reason why we want to give you a little bit of understanding of what is this program, why is it designed this way, and what do we want to achieve by the end of the academic year, right? Then we share certain checklist and then some of the questions that we have often been asked, so that that will actually help you in effective program implementation in your classrooms, right? So are we all clear? Like, first understand how do we do this hands-on experiential learning, then ensure that we know how to uh, move around the Super Teacher app to use it effectively in your classrooms, and then how to use your content books, workbooks in your regular teaching. Then a little bit of understanding of what is this program, why is it designed this way, and how do we get to actually deliver based on the way it is kind of designed. And then few questions or few checklists that will help you ensure that you're doing a good job in your day-to-day classroom teaching, right? Now I want all of you to type one word in the chat. uh, what is that one word that comes to your mind when you think about, okay, this is what my kid should be learning as a part of the computer science program? What is that one goal that you want to achieve uh, through a good computer science program for your kids, right? Put it in the chat. What do you want to achieve? Or what do you think the program should deliver to the kids, just in one word? Yeah, put it in the chat, please. Okay, I think Amita ma'am, we'll look into it, ma'am. Learning chart. Okay. Others, please, let's generate curiosity, adoption, aim, logical thinking. Others also, please. Innovation, great. Friendly with programming. Okay. I think things are changing. Now the way we have written code a couple of years back is not the same way we are writing code now. So operating computer, digital literacy, great. Others also, I think we have a lot of participants as a part of the training. Then would like to hear more of your thoughts. Rational thinking and database management, great. Make it student centric and also ensure hands-on experience, great. New ideas to develop. Okay, I think a lot of rich thoughts. Others also, please don't wait, or tech friendly. Okay. Others, please do not hesitate to type. What is that one thing that you want your kids to develop from a good computer science program in this current age? How to create a program, world of computing. Okay. Uh, Got it. Learning manageable steps, digitally critical thinking. Great. Okay. So I think there are a lot of rich thoughts, or as in like what should the technology education be, and then what do we want to achieve by it, right? So we'll also understand like what is our program and how is our program aiming to do something like that, right? So this is also one of the activity that we started doing it last year. So we'll again do it this year. But how many of you are attending in either pairs or groups this training? Is there anyone who is attending the training as a group or a pair? Anyone in this training group that you're attending as a group, or you're attending it together or something like that? So that this activity will be much more effective. Like if you're doing it individually also, that would be great. But if there are people who are attending in either pairs or in group, I think that will be much more effective. Okay. Fine. So coding, problem solving, great, great. Okay. So what is this activity about? So maybe what I would say is if we have teachers who have attended the last year, can you tell me what is this activity about, ma'am? Anyone who has attended the last year? What do you want to do out of this? Please, if you can raise your hand, that would be great. I think let's make it more a two-way communication. Is there anyone who would like to share what is this activity about and what do we want to do? Salma ma'am, would you like to share what is this activity about for all the other, I mean, the new teachers who are teaching this program for the first time? Someone who would like to explain it to others? Anyone? If there's anyone who is willing to, I mean, speak up, please raise your hand. I'll just allow you to speak so that you can tell it to the people like what is this activity about. Anyone? The cat needs to move. How it needs to move? There's a question, right? So here is an activity. There's a small grid. There are these three things on the grid. So what do we do is here you have this cat. I think in our nomenclature, it's called as a sprite. Coding Scratch, it's called as a Scratch sprite, right? So here is your cat, which is your sprite. And then there are these three things that you want the cat to do. And then how it goes is like it has to go through this particular grid size, right? So now you're free to choose the path that you want. Okay. But what are you expected to do? So please hear it very clearly. And then you have to put your instructions in the chat, right? And most of you are kind of attending this individually. So what I want you to do is, so let's hear the problem statement. The problem statement is here is your cat and it has to navigate through the grid and it can go the way it wants, but it can only follow the instructions that you give it to the cat. Cat cannot think it for itself. It doesn't have brain, right? So it only follows the instruction that you give it to the cat, right? So now what is the instruction that you need to give it to the cat? This cat needs to do couple of things, right? What it needs to do is it has to pick up this gift, right? Then it has to go for this cake cutting. Then later it has to finish it off with having food. So three things in sequence. One is like it goes and picks the gift, next followed by cutting the cake, then followed by uh, having the food and then leaving the party, right? So now, what do we want to do here now? So here, what is expected is you have to give instructions for the cat to follow so that these three things are done as per our expected sequence. So now what I want you to do is just think through it, okay? Or if you have any questions, you can ask me before you write your instructions. But think through it. You're giving an instruction to your cat, making it follow through this particular grid size, and it has to do these three things in sequence. So now how do you write your instructions? Just put it on the chat and so that I can read how you're kind of thinking. So whoever is kind of ready, please put your instructions in the chat so that we can move forward. Or before writing, is there any question that any one of you have? Or do you have all the required informations to solve this? Anyone, any question? Or do we have all the required information to solve this activity? Okay, Alka ma'am has put first three steps up. Great. But ma'am, like anyone, any questions before actually we doing this activity? Okay, I think a lot of you are actually getting into solving the puzzle, right? So I think the very first thing that we should all like, this is a problem statement that is given where we have a cat. There are these three things that it needs to be done as a part of this puzzle solving. But I think the most important thing that we need to ask before actually jumping is, what instructions does my cat follow? Right? Does it follow English? Does it follow Hindi? Does it follow any other language? Or what instructions? Because using those instructions alone is where you can give commands, right? So that is very important, right? So before we directly jump into the problem solving, the first question to be asked is, okay, what are these instructions? What does my cat understand? So here is what your cat understands. It only understands the command of move forward, move backward, turn left, turn right, or move up or move down. So these are the only instructions which your cat follows. So now using these instructions, guide your cat to do these three things in sequence. Okay. So I think Amita ma'am, Pavitra ma'am, Alka ma'am, and uh, so I would want you to relook at your the way you're kind of writing your instructions to fine tune it to the way how your cat actually understands what we are talking, right? Rajita ma'am, you had a question? Rajita ma'am, you had a question? You can unmute yourself and then ask the question, ma'am. Also, Sheikh Salma ma'am, you had a question? Okay, fine. So with yes, ma'am.
Ma'am,
Yes, ma'am.
two steps, ma'am.
You have a question, ma'am? Salma ma'am?
Yes, good morning, sir.
Good morning, ma'am.
First, cat moves forward two, three steps to get the gift. Again, take
Forward or move up?
afterward, it will take right and come down and take right again to get cake to cut the cake. Again to move forward. Again turn up to have the food.
Okay. I think how many of you agree with these instructions? Are these instructions the right? Ma'am is saying move forward three steps. How many of you are fine with these instructions? Just check the way your cat is oriented. No, your cat is like this. It's facing this direction. When it goes, when you're saying move forward, does it move forward like this or does it move?
Move forward up.
Ah, okay. Others, please put down your instructions in the chat. Okay, I think Shivani ma'am has asked how cat will move in the boxes. Ma'am, like in one step, the cat can move in only one box, right? It cannot jump through multiple boxes. One step, one box. Two steps forward, two steps down.
చెప్పండి.
So whoever is done, I think just put it on the chat. Two steps forward, two steps down.
మేడం మేడం అన్మ్యూట్.
Let's do it quickly. I mean, who is there anyone who has done this activity? Finished? Put it in the chat, please. I think while you are writing the instruction, just check the orientation of your cat. Cat is facing towards this direction. It's not facing upwards, right? Move forward is like this. Move up is this. Move up or move down. So based on that, please write your instructions. Okay, Pravalika ma'am, move up, take right, move up, again, take left. But maybe ma'am, like you have to mention how many steps it has to move forward, no? At one single time, your cat can move only one step. Someone who has finished this activity, just put it on the chat. Your instructions. How do you guide your cat to do this activity? Nine steps. Okay. Shada ma'am, what are your nine steps? Just put it in the chat. Like, okay, you ask the cat to do first this, followed by this, followed by this, followed by this. Okay, Pavitra ma'am says move up three steps, get the gift, move forward two steps, turn right, steps to cut the cake, and move forward one step, turn right, and then eat the food. Great. Deepali ma'am. Ma'am, Pavitra ma'am, is this your first year or first year teaching CS Exceed program, or this is your second year? Deepali ma'am, turn left, move forward for three blocks, move forward two blocks, then. Ma'am, Deepali ma'am, I think it's great that you have said turn left before actually moving forward. I think that's a good thing that you are kind of noticing so that you're giving the right instructions. But you haven't given your instruction to the cat to either pick the gift or cut the cake. Do you think that should also be part of the instruction? Because cat cannot think for itself. Turn left, move up three steps, present the gift. Okay. Turn right, move down three steps, turn left, cut the cake. Turn left, move two steps, turn right, have the food. Great. Okay. So by moving right two times, then move up. Okay. I think it's good that a lot of you are kind of posting it on the chats. Now, once most of you are kind of done with this activity, right? I think what is important is read through your whole instructions, right? Whatever the instructions that you have put, assume that your cat doesn't understand or doesn't apply its own brain. It only follows the instructions that you have written, right? If you have asked it to go right, it will go right. If you asked it to sit, it will sit. If you asked it to do something else, it will do it, right? So reading your instruction, just think whether the cat can easily follow your instructions and get the job done. If not, did any one of you feel that, okay, there was some confusion, I need to rewrite the steps in a different way? If anyone has felt something like that, put it in the chat. So what I mean is go through the instruction that you have put and be yourself in the shoes of a cat, saying that, okay, it cannot think for itself. So it is just blindly following your instructions. So is the instruction that clear that it can get the job done? If not, if you feel, any one of you feel that, okay, these instructions are not enough for my cat to get the job done, so why do you think those instructions were not enough, and what changes would you recommend? I would like to hear from a couple of people who feel their instructions were not good enough. Anyone? Anyone you felt who has written these instructions and then felt that, okay, maybe I have to rewrite these instructions in a different way for my cat to understand it a little better? Have anyone of you felt something like that? No one? So all of you are happy with the way you have written your instructions. Okay, who's this? Yes, Rajita ma'am, you want to share something? Okay, fine. So now I think all the struggles that I mean all of us had, where we have assumed that our cat understands a couple of things, and then based on which we have written instructions, right? So this is very similar to what you would find when you are making the kids do such kind of activities in the class, right? So I want to hear from the teachers who have taught the last year, like how would you help your kids in actually getting these activities done? What kind of questions would you ask? So let's be specific to this particular activity. So considering that this is just a grade 2 kids who are expected to do this activity, so where do they generally struggle? So if you can put it on the chat, or it would be great to hear some voices. So it would be more useful to hear from teachers who have taught this last year. What is your experience? Like, where are the areas where your kids are struggling? And then how did you help them solve the things that are expected to be done as a part of the activity? I think teachers who have taught the last year computer science would like to hear your voices. Great if someone could unmute, raise your hand so that you can share your experiences. Anyone? Is there anyone who would like to share? Or okay, all the year one teachers also, that's great. So if you are expecting a grade 2 kid to do this activity, right? So what kind of questions do they generally have, and where do they generally struggle? So can someone put it in the chat? Can someone put it in the chat, considering that this is an activity that we want our grade 2 kids to do? So what kind of questions will they have, and where do they generally struggle based on your experience of teaching kids? Anyone? Please put it in the chat so that it would be good to know. Okay, I think this is very important. They struggle to figure out what is right, what is forward, what is backward. Great. Anything else? Anything else? Where do they generally struggle? Anyone else? Okay, if they don't follow the instruction, they feel the struggle. Great. Okay. But let's be more specific. Like, what are those areas where they generally struggle? Is it easy for the kids to navigate directions, or do they understand like what is the sequence about and all those different things? If you are just getting them to do this activity in the classroom, and if they struggle, like how would you help them solve it? What kind of questions would you ask? No one? Okay. So here, I think our whole program has this inherent thing where whenever we are kind of teaching them a particular concept, we make them do an activity through which they explore the concept, right? Say for suppose, for all the teachers out here, how do you use this activity to teach the kids a simple concept of sequencing? How would you use this activity to help the kids understand the simple concept of sequencing? Anyone? So you have just made them do this activity. So now how do you use this activity as a medium to teach them what the sequencing is? What is the concept of the sequencing? I think by using directions. Okay. Others? Just think, how do you use this particular activity to teach the simple concept of sequencing for the kids? Anyone? Okay. So all the teachers who have, okay, I think something using these directions and follow the instructions. Okay. Okay. And remembering the birthday party of the friends. Okay, fine. So now let's see how we use an activity, something like this, to help the kids understand the key concept of what a sequencing is, right? So all the teachers who have access to the Super Teacher app grade 2, I would request you to open block 4, right? If you can, I'll just also share it with you. So how do you access it? Okay. So for you to access it, go to your grade 2, right? And move down to block 4, right? Just open block 4 and then please go through this particular lesson plan, right? And then we'll have a quick chat. So I'll just give you 5 minutes. And if there is someone who is not having access to this grade 2, please let me know so that I can share the screen for you to go through it. Yeah. And Farhat ma'am, yes, the activity teaches sequence because students give instructions step by step. They learn the order is important to complete a task correctly. Great. So let's see how is this how is this happening in our lesson plans? I think there are few teachers who said like they don't have access to grade 2. So let me just what I do is I'll just open this Super Teacher app, scroll through this, then solve them by using live practical hands-on. Okay, so let's quickly go through this particular lesson plan. So this here is the lesson plan for grade 2 where we are using this activity, right? So now here there's something called as teacher summary. And people who don't have access, maybe you can see through the screen. I'll scroll through very slowly. So you can read through what is there in that. Then later we can discuss what we need to do, right? So there's something here, key question, why is it important to follow steps in the right order? Then there are certain resources. There is this paper maze, this is the activity, content book, workbook. You will be able to access this content book here. We'll come back to what each of this is. At the moment, it's only to understand like how have we integrated that activity into teaching. So this is a grade 2 lesson where we are kind of teaching kids what is sequencing as a concept is in computer science, right? So there are these some 5 steps: aim, action, analysis, application, and assessment. We'll come down to that later. So here is the action where we are making the kids do this activity. So they do this as a group activity. We give them instructions and ask them to work together. So while they are putting it up, they have to first draw it on this worksheet. So you share this worksheet with kids of each group, and using pencil, they'll just put the directions that the cat needs to follow, and then later write down the steps on the paper, right? Then we get into discussing what happens if the scratch cat doesn't follow the steps in the right order. Then we show them that why do we need to follow the steps in the right sequence. And here is where we are introducing them the concept of what sequencing is about, right? Then we are connecting it to saying like, can you think of something in real world where the wrong order could create a problem? So share with them couple of examples which they understand and relate to. Then there's something called as coding connection. So it is building on this particular activity, but connecting it to how the kids code using the Scratch blocks, Scratch Junior. Then they have this small video. You're able to hear the audio of the video?
Imagine trying to drive a car before turning it on. Would it work? No way. That's because we need to do things in the right order. This is called sequencing. Sequencing is like brushing your teeth. First, pick up the brush, then add toothpaste. If you do it out of order, it won't work. In computers, sequencing is super important too. To help Scratch Cat move in Scratch Junior, follow these steps. Move forward by 2 steps. Jump. Move forward again. But if you mix up the steps, like jumping first or moving forward thrice, Scratch Cat might not do it right. So remember, sequencing means putting steps in the right order, at home and in programming. Computers need us to give clear instructions.
Okay. So we have taught them this concept. They're going through this video, and they have this simple worksheet which makes them apply. Okay, there's this ice cream sundae. So they have to order the steps, look at this, and then write the instructions. And here, use these blocks to write. Okay, just decode what each of these blocks is making the sprite do. Okay, so this is a simple worksheet here. Then there's something called as homework. Then there is assessment, right? So now maybe I'll again slowly scroll through so that you understand all the different elements in this lesson. Then we'll quickly have a chat about what have you observed, right? So the lesson has these 5 steps. It starts with a key question. You have all the resources that probably you need for teaching this classroom. Then there are these 2 keywords which are important for this lesson. Sequencing is what we are teaching them. Instruction is also something that if they don't understand these 2 words, kids might struggle to understand and relate to what we are teaching. But the class starts with an activity where the teacher guides or gives the instruction of what needs to be done. Then after the activity, we are discussing it with the kids, saying like what will happen if the right order is not followed, so that they understand why the necessity of the right order and writing the clear instruction. Then based on that, we are connecting it to the concept that we are kind of teaching, then connecting it to the real world. Then there's something called as coding connection, which connects to the computer programming. Then there's a small worksheet, then there's something homework, and then assessment, right? So how many of you after doing this activity and seeing the kind of lesson plan, this is for all the new teachers, so what is the role of this particular activity in the way we are teaching, and what do you think about the way the lesson plan is structured? think of like you're a grade 2 kid who's expected to be learning this particular lesson in the classroom, right? So be in their own shoes and then share your thoughts. What do you think about this lesson? And then how does it help them understand this key concept of sequencing in computer science for them? It would be great to hear a couple of voices. If not, at least put down your thoughts in the chat. So is it clear? Like, what are we expecting to do? So you have seen the activity, gone through the particular lesson. So now, how do you think this particular lesson plan will help kids of grade 2 to understand the key concept of sequencing in computer science? All the new teachers. Okay, it will help as a student to think the steps of instruction before we do anything so we get the right output. Great. Okay. Others? Anyone else who would like to share? This LP helps students to go through the right direction with proper instruction. Then they have to learn the instructions, anything to do in the computer. Great. Okay. Others, I think good that a lot of people are engaging, but there are a lot of people who are attending the training who would like to hear other voices as well. And okay, so just moving on, do you think was there a structure to the lesson plan? Were there any structure that was being followed in this lesson plan? Did any one of you notice? And were there any components that you are seeing? What each of this component was trying to do for all the new teachers? One, what is the structure that you're seeing, and what are the various components that you're kind of noticing in this lessons? So I'm slowly scrolling through. Just keep a note of like, do you find some structure to it, or what are the key components that you're finding it in this lesson plan? Okay, there's a 5-way method in this lesson plan. Kids are understanding sequencing and ordering. Okay, 5-way method is right. So now, ma'am, like Pavitra ma'am, can you help us understand what is this 5-way method so that others also know if you're clear about what it is? Pavitra ma'am, would you like to share it with others? Like, what is this 5-way method? Or I think even the teachers. Yes. Yes, ma'am. Pavitra ma'am. I think you can unmute yourself and then share what is this 5-way method.
Good morning, sir.
Yeah. Good morning, ma'am. Yes.
Finally, looking at there is a parliament that is use, like say, analysis, application, and assessment. What we following other subjects, like that in computer also we are following the IA method.
Okay. But can you tell for all the new people who might be teaching this method for the first time, what each of the step is and what do we want to do?
training is saying what we are learning.
Okay. Maybe I think your voice is a little, I mean, not quite clear. If you can help us understand what is this action about, then maybe we'll move to other steps. We might hear from others also. What is action about, ma'am, in this 5A? Or I think a lot of teachers are putting in this is a 5A exceed method. So can someone tell what is this action about? What is this action about?
Practically, we are learning.
It's a practical learning. Okay. What is activity about? Someone can put it in the chat. What do we do in activity? Is this an activity? Giving commands to the cat. Okay. Okay. So maybe what is it is for in the interest of for everyone. So I think if you just see here, the structure that is being followed in this classes is like it follows the 5-step exceed process, right? So now what is this 5-step exceed process? I think for all the new teachers out there, so you have a 40 minutes class, right? So in this 40 minutes class, the aim is nothing but what do you want to achieve by the end of this 40 minutes, right? So you should have a very clear goal, as in like in this 40 minutes or 35 minutes that you have. So what do you want to achieve? What do you want your kids to achieve by the end of this 40 minutes? So that is one of a very clear goal that you want to have at the start of the class, right? Now, as a part of our exceed way of teaching, we always follow this 5-step exceed process, right? So in this, there's something called as an action, right? Action is the way we kind of teach as a part of exceed. Action is nothing but before you make the kids do something or learn something. So what do we want to do is we want to make them do an activity. So here in this case, the activity was solving this particular puzzle where we kind of, sorry, 1 second, solving this puzzle where as a teacher first you give them instructions saying that okay, this is what this activity about, these are things that you have to do in a group. So first, before teaching them anything, we make them do this activity, and the whole idea of this activity is to ensure kids while doing this activity experience the concept, because in this whole lesson the concept that is being taught to the kids is about sequencing. So we are not actually teaching them what a sequencing is at the start of the class, but we are making them do an activity through which they understand, oh, why is this sequencing, what is this sequencing. So it just makes them think about the particular concept, right? So that is what your action step is all about in every single classroom. Then followed by when you come to analysis, now that your kids have already done the activity, they finish the activity through your guidance, right? So you have helped them, but as a teacher, your job is not to help them come up or give them the right answer in the activity. It is to ensure that, like, I think while we were doing this activity, there were a lot of teachers who have assumed something or didn't think that, okay, you need to give the instruction for the cat to say, pick the gift or cut the cake or eat the food. Until and unless you don't give the cat this instruction, it will not follow, right? So we are not giving away the answer, but we are making the kids think through it and then come to that particular conclusion. That is what you as teachers are expected to do, right? We are not giving away the answers, but we are asking them the right questions which will lead them to do the right answers, right? That is what you will do as a part of activity. Then comes this part called analysis. Analysis has these two parts, something called as an activity discussion, then it is called as a generalized discussion, right? So in this activity discussion, the whole goal of this activity discussion is because they have done the activity. Now, the way we are kind of asking the questions to the kids should make them share their experiences of what they have done in this activity, right? So the activity discussion is to first ensure that the kids are kind of we asking them the right questions. We ask them to share their experience of doing this activity, what did they learn out of this, and so you have all the questions that are there which you probably use it in your classroom, right? So one, under the analysis, the first step is about discussing the activity, making the kids open up by sharing their experiences. Again, it is in their own words. Here you are just asking them the questions, you're just facilitating the conversation to lead them to the concept that needs to be taught in the class, right? So once this activity discussion is done, then you get to your generalized discussion. So now what is the idea of this generalized discussion? Now the kids have done the activity, they have shared their experiences of what they have done in the activity. So now you connect their experiences to the concept that needs to be taught. So the concept that we were kind of teaching them is what is the sequencing, why is the sequencing used? So helping them, like they have done an activity, connecting it to the sequencing as a concept. That is what you're expected to do as a part of your generalized discussion, right? So now once this generalized discussion is done, so the kids have done an activity, they have shared their experiences, and they know what is the underlying concept behind this, right? Then the immediate next step is making them think, okay, where in real life do you see an application of this concept, right? So that is where the next, component of the lesson goes in, where like once they understand, you have to make them see where is this simple concept being applied in their day-to-day life, something that they can see around, something that they understand and relate to. So that's how we kind of get the teaching experience live into this particular classroom. So all of this is kind of planned for you as the lesson plan. You need to follow the instructions and then deliver it in the classroom. And then based on your experience of tackling your schools and kids, and then your experience of teaching, you can add more value. But this is the structure that you generally follow while teaching it, right? Then comes this important component of coding connection. Now, the teachers who have taught the last year, what is this coding connection, ma'am? Can someone help us understand what is this coding connection? What is the purpose of it in the classrooms? Someone? What is the purpose of this coding connection, and what do we want to get out of this coding connection in every single classroom? Anyone? Okay. So the purpose of this coding connection is nothing but, so far in the lesson, the kids have done an activity which was related to the sequencing. Then they shared their experiences. Then we said like, okay, what was this concept? What is this sequencing about? You have taught them what sequencing is, and then they were also able to connect it to the day-to-day life. But they are kind of doing this, give step-by-step instruction to complete the task. No. So the coding connection is now the concept of sequencing. Now the question is, because it's a computer science class, they should be knowing how this concept of sequencing is used in programming, right? So that is what we kind of teach in the coding connection. The idea of the coding connection is you have taught them the concept, and once the kids understand what this concept is and they can explain it in their own words and also connect it to the things that they see around in day-to-day life, now the immediate question that comes in is, okay, how do I use this in the programming? So that is what the coding connection in every single classroom teaches, right? So they have learned sequencing. So they have done instructions on the this small puzzle piece where they have done, right? So now what we are doing is we are kind of connecting it to the Scratch Junior, which is the program that they will use to code. So this is kind of grade 1 and 2 kids. So grade 1 and 2 kids use Scratch Junior program to learn to code. So based on this experience of doing this activity, so we are saying that, okay, if you want a program to be run where you're kind of giving instruction for the sprite on a computer, this is the way you kind of arrange the code blocks. So the order in which you are arranging the code blocks defines how how your cat responds to your program. So that's how we kind of establish the connection between what they learn to do, what they learn while doing this activity, to how they are actually coding it in their real day-to-day life. That is what we kind of tend to teach through this coding connection, right? So once this coding connection is there, so the small video that you have in the classroom kinds of consolidates whatever that they have learned, where the simple concept connecting it to the real world, and also it connects it to the programming. So helping them connect all of those dots is something that this video does. So it's a small video. Depending on the age group, it is from 60 seconds to 120 seconds is what we have across the grades. Then now that the kids have understood, now it is the time for them to just share, like, okay, what is something that they have understood it in their own words. So that is what we do as a part of this application step, where there is a simple worksheet. And in this worksheet, you always find three questions. Question number one, question number two, and then question number three. And then in these three questions, why do we have three questions in the program, right? So here, the reason we have these three questions is because you're all teaching in the classroom, and all of your classrooms are not a homogeneous group of kids, right? So each of them learn differently. So now, according the way we kind of design our product, we kind of bucket the kids into three different categories. There's something called as an approaching category. These are the kids like who need a little bit more support in helping them understand the concept. So that is one type of category of kids whom we call as an approaching kids, right? They need a little bit support from you to help them understand the concept. Then there's something called as a meeting category, right? Meeting category kids are the kids who understands whatever that you're teaching, right? So whatever you teach, they easily understand it, and then they can apply it to get stuff done, right? And then these are all the kids who are there in your class. Then we have something called as an exceeding category. So exceeding are the ones who are smart, who can go one step ahead compared to what you're kind of teaching. So always your worksheet is kind of aimed to a approaching, meeting, and exceeding category, right? So now, as an instructor, your goal is to ensure that every single classroom that you're teaching is to ensure every kid in your classroom is kind of getting to a meeting level. We are not aiming for an approaching, we are not aiming for an exceeding, we are aiming for a meeting level category. Ensure that every kid in the classroom is at least coming to the meeting level. So that is what it is. And then if you see the bottom of that worksheet, so this is what for us meeting level rubric would mean. So by the end of the lesson, you want to ensure that every kid in your classroom is kind of coming to that meeting rubric, right? And then you, depending on if you get time to evaluate these worksheets, you can just click, put in the feedback here, like whether they need more practice or can do or does it really very well, right? So this is the worksheet. Then in the same worksheet, like if you see in your books, there's a small rubric. I'll just show you sometime later. So every worksheet has a rubric. Like what does an approaching category rubric means, what does a meeting category rubric means, and what does a exceeding category. So this is basically what you generally see it in your books, right? So any quick questions on the structure or anything that comes to your mind at the moment? Anyone? Any questions? Is it clear, or was it anyone, any questions? Feel free to put it on the chat. Or if there's something that you would like to share, please unmute yourself or raise your hand. Anyone? Okay. So then maybe I think let's put it this way, where can someone put it in the chat? What are the key elements of the Super Teacher Computer Science lesson? What have we understood so far? What are the elements of this computer science lesson? Anyone? Just put it in the chat based on what you have understood. Just put it in the chat, like what are the different elements that you see it in this computer science classroom. Anyone? Okay. So let's quickly understand this. I think it's just a quick recap of what we have done so far. So always your lessons of Super Teacher Computer Science program follows this five-step exceed process. There's an aim, there's an action, there is an analysis, there's an application, then there is an assessment, right? So it always follows this five-step process. So now in this five-step process, now what is it? First, you first set what do you want to achieve by the end of this 40 minutes. Then there is an action, which is nothing but an hands-on activity that you want the kids to do, right? Then there's something called as an analysis. The analysis is nothing but it reflects on the activity through teacher guiding this conversation by asking them the right questions and then later connecting it to the concept that needs to be taught in the class. So that is what we do as a part of analysis. Then under that analysis is what we also have something called as coding connection. Because so far in the lesson, we were teaching them the concept and connecting it to them in the real day-to-day world. But they should also be knowing how is this concept used in programming. So that is what your coding connection does in your every single classroom, right? So first it starts with an aim, followed by an activity, which is nothing but action. Then immediately after action, you get to discuss what the kids have shared, then connecting it to the concept. And once the kids have understood the concept, then we'll help them understand, okay, how is this relevant to you when you're actually programming it? That is what your coding connection is all about. Then once they understand the concept, then they get to the application where they do this small worksheet with 3 questions. And then we kind of summarize the lesson with some key takeaways. Okay, is it clear? Any questions, anyone? Okay. So now I think for all of you who are kind of using the app for the first time, right? So now if you just go through the whole app, there's something that we should be understanding, right? So one is we go via something called as a block-based approach. Okay. So now what does this block-based approach mean? So the block-based approach means like block is nothing but what do you want to do in one single week. So this one single week has 2 lessons. One lesson is in your classroom lesson, which is something that we have seen, then followed by there's something called as a lab lesson, right? So now say for suppose this class is happening on your Monday, right? So Monday is where you're teaching them the concept of sequencing. So for this class, you need not be in the computer lab. So you can be sitting in your own classroom where you're not using your digital device, but following this exceed five-step process, you help the kids understand what is the sequencing about in your classroom. Next, in the other day of the week, say for suppose this is on Thursday. So now Thursday, they come to your lab. The idea is the concept that they have learned, which is like sequencing. Now they apply that particular concept to create a project in their lab. So maybe for the same block, let's understand what is this project that the kids are doing. So in their classroom class, they have learned what is the sequencing about as a concept. So now what they do is they arrange the blocks on Scratch Junior to make this chicken sprite dance, right? So we go them step by step. So I'll also show you in the books what are we expected to do. So here what do we do is we first they learn the concept in the classroom where follow the five-step exceed method. They understand what is the sequencing as a concept is about, which is happening, say, on Monday. Now they come to the lab on Thursday, and Thursday the goal is make them apply the concept that they have learned on Monday, which is sequencing. And using that concept is what we make a simple program that the kids will develop. And here the program is about how to use sequencing as a concept to ensure that you are making this chicken sprite do a few dance moves, right? This is what is expected to be done, where we go step by step, right? So here, if you open the lesson plan, you have a step-by-step instructions on how to open your Scratch Junior, how do you place your Scratch chicken sprite on, how to add the backdrop, how do you position it. Then you go step by step in actually building this program, because the whole idea was to apply this concept of sequencing to create program that makes the sprite dance, right? So you go step by step in helping them understand how to go ahead building this particular program. And by the end, they know that, okay, this is the order in which the code blocks needs to be arranged for the program to work. So this 40 minutes in their lab, they are either working as individuals in their lab, or it could be a pair activity, or it could be a group activity, depending on the number of systems that you have in your computer lab. So what the kids are doing is, maybe if they are working in pairs or groups, that would be great, where at least each one does take a turn to get stuff done, right? So that is also one thing. So where as a teacher, you should get your right group mix correct, so that it's not like all the kids who are very into, or who are quite smart are in the group, and then there are kids who are struggling a little are all there. You should ensure that there is this right balance in the groups, so that there's learning that's kind of happening across all the people who are part of it. And we also have different kind of blocks, which we'll come to understand it later. So it would be great if they are kind of doing it in individual. If not, I think what is it is they can do it in pairs or groups, depending on the infrastructure that you have in the school. So every week they'll have two classes. One class is happening in your classroom, where the idea is to teach them the core concept. And that's where we follow the 5-step exceed method. And once they follow this 5-step exceed method, then the other day of the week is where they come, where they apply the concept to create a project. Right, so that is how each of your block is there. So we have different kind of blocks across the grades to help the kids understand various different concepts as a part of the program, right? So every week there will be two classes, one classroom class where it is about teaching them the concept. Then the second is the lab class, where they apply the concept to create the project. Yes, any questions so far? When we complete the practice questions. Okay, I'm just coming. So any questions? Every block will have two lessons, one classroom lesson followed by a lab lesson. Right. So far, what I have been showing you is something that the you are able to see it on the Super Teacher app. So this is what you as teachers are only able to access it. Your kids will not be able to access it. And also for the new teachers, say for suppose if you have smart devices in the classroom, and first is this the app gives you two views, right? So whatever is the view that I'm kind of currently showing is something we call this as a teacher view. So this teacher view is nothing but for teachers when they have to prepare for this lesson plan. This is what you can kind of use. But if you have a smart device and then you want the same lesson plan to be projected into the smart device, it could be a projector or a smart device or anything of that sort. What you can do is you can just click on this, the top right icon here, this top right icon, which is called projector. So this will kind of convert the same lesson plan into something called as a student view or a projector view. So here the idea is the same 5-step method is now broken down into presentations, right? So you don't have to create any presentation. So the same lesson plan is kind of now converted to the projector mode. Now, if you want to increase the font size, you could do it depending on how you're kind of using it, right? So there is this functionality for choosing the right font size, right? So you can go step by step, where the aim you can deal with it, then action, then analysis. So you can follow the right sequence and ensure that you're delivering this lesson plan as it kind of expected, right? And in the same way, what you also have is, this is your classroom lesson, Then it is followed by your lab lesson. And here in the lab lesson, and a lot of teachers last year, when they were kind of teaching it, because we have this notion of using the books for teaching, right? But the Exceed, our recommendation is whenever you're kind of teaching your lessons, right? So especially in the classroom lesson, where the idea is to help the kids understand the core concept using the 5-step Exceed method, my only request is please do not make them open the books. Follow the lesson plan, help them understand the concept following the 5-step Exceed method using what is there on the Super Teacher app. Kids can read through what is there in the content book because they are coming to your lab only on Thursday, right? Because your Monday is your classroom class, then is your lab class. So now the whole idea of your books is, if you see a lot of books, even when we were reading and for ages, computer science books were never quite interesting for the kids to read. Either they were too technical or something not easy for anyone to understand and then relate to. So that is what we kind of try to change the notion of making computer science more engaging, interesting, and relatable for kids. So as a every week there are 2 classes. The book also is divided into 2 components, right? Now, because you have taught them the concept of what sequencing is using Exceed Super Teacher lesson plan, so kids can go back home and then go through the content. Because these are nothing new that we are kind of teaching. It's mostly what you have taught them using the lesson plan, right? So they go through it, they kind of quickly read through what is there in it. Then after doing it, before they come, they have to do this something simple exercise called My Learning Chart. Sorry about that. Now, because when they read through the book, right? When they read through the book, now this My Learning Chart is a simple exercise which is there at the end of every classroom lesson. Okay, I'll just come to that. So because how will we understand how well has the kid understood what was being taught? So this is a simple activity which is called as My Learning Chart. The idea of this My Learning Chart is nothing but us as educators, right? We should be understanding what our kids have actually learned from this particular lesson. So it is by making them do this simple exercise at the end of the class is what we help them understand how well they have mastered that particular concept. So this is nothing but an activity that summarizes whatever that they have learned in this particular lesson, right? Then followed by practice questions, which you can give it to them as a homework. Now, I think the other thing is, say, I'll just show you. You will be able to access the answers to both your My Learning Chart and practice questions as well on the Super Teacher app only. Okay, so maybe I'll just quickly show you that. So if you go to your lesson plan 1, I think there was some, if you just scroll down, homework. So this is what you'll give it as a homework. Then there is a small icon at the button at the bottom here, show answers. So if you click on show answers, so for every single practice questions, what you also have is model answers, which kinds of give you like what is the kind of responses that you're expecting from the kids, right? So this is something that you're able to access it on the Super Teacher app. And in the same way, for the worksheet that you make them do it in the class. Now, for you to prepare well, expecting like what your kids can do, so they'll be able to see what is the answers that you are kind of expecting. For that, you have to come to this assessment. Now, again, at the bottom, there's the show answer button. So now if you click on the show answer button, there will be an worksheet which is kind of filled based on what is the response that we are expecting from the kids, right? So under the homework is where you will be able to see the practice question answers. And if you come down to the assessment here, and if you click show answers here, you will see the answers to the worksheet. And this is something that only teachers have access. Kids do not have access. So you will be better prepared when you go to the classroom, expecting like what is the kind of responses or how do you have to guide the kids to come up with the kind of responses, right? So that was for the classroom lesson. Now, I think there was a question that was put up on the chat also. So here is like when we want a lab class. Now, how do we actually teach a lab class, right? So in this lab class, now one is because you're teaching young kids who are kind of doing this for the very first time, right? And maybe they would have learned it in grade one if they were using the Exceed Super Teacher program the last year, right? If not, what we'll generally do is, because the way the lessons are kind of structured is in a way that most of we are kind of assuming that the kids might be learning these concepts for the first time in this particular academic year, right? So while teaching the lab class, what you're expected to do is, because this program is about creating the sprite to dance. Now, all the teachers, you will be aware that when your kids are there in the lab, it's how difficult it is for you to get them to focus and then work on a project, right? So in order to solve for that, what we have done is, as I've told you, classroom class, please do not make them open the book. But in the lab class, I'm asking you to please make sure that your kids are opening the books. And what is the reason for that? The reason for that is the step-by-step instructions that you're seeing it on the Super Teacher app, they are also printed on the book, right? The same instructions that you see it on the Super Teacher app are also printed on the book. But now, how do you teach a lab class? For you to teach a particular lab class, because you're teaching it to the young kids, so first thing that we need to do is first help them understand what we are building. So it is about a simple program which makes the character perform some dance moves. So very simple English, what do you expect them to do as a part of this particular program? Then connecting it to what are the important blocks that they are going to use. Because it is about what is this green flag about, how do you use your right block, move left block, or hop on, hop off, right? So first they should be understand what each of these code blocks are expected to do, or what will they do if you are using it in the program. So that's the first thing, right? Then what we do is we do them a quick demonstration of this particular project in front of the whole class, saying that how do you go step by step in actually getting this product built, right? So first you tell them in plain English what they are expected to do. Then you help them understand those important blocks which you are going to use it in your classroom or for this particular program in specific. Then for the whole class, you give them a quick demonstration of how this product needs to be built, right? And here is where like a lot of teachers, one of the important thing that we have done based on the experience of last year is, and for most of the teachers, I think it is a good advice to first build the program beforehand by yourself. So you know your kids better, you know the areas that they struggle better. So most of that could be tackled in your first demo that you do at the start of the class. Now, once they are done with the demo, what they can do is they can go back to their computers, open the book, because you would have shown them the same step-by-step instruction as what it is. So you need not give them multiple demos for getting the project done. What they can do is they can read through the instructions, and even if they struggle to read through the instruction, they see through the visual and then get the job done. So that's the reason why I'm asking you to open the content books when you are there in the lab. Clear? Right? And even if some of your kids who really struggle to finish the project on time, they can still go back and then work on this project because all those instructions are printed on the book. Okay. Now we had a homework for our classroom class. We also have a homework for our lab class. That homework is nothing but your do it yourself section. So this do it yourself is a project that they can do it at home, which is very similar to what they have done in the class. And they can do it at home because most of our programs that we are using, they are all mobile friendly till grade 4. So they, even though if they don't have a laptop, that's okay. They can try to doing it on the mobile phone, just installing Scratch Junior or Scratch or other softwares that will give you access to. So they can just use it in the mobile phone and then get this projects done, even if they say struggle with not having the computer at home, right? So this is what each of the blocks, that's how each of the blocks are kind of designed, and then what we are expected to deliver per week, right? So any quick questions here? Or are we clear on what it is, or any confusion? Please feel free to ask. And for all the new teachers, how do you see this way of learning computer science, or this way of teaching computer science for the kids? Quickly. Anyone else? Please put your thoughts on the chat. Let's quickly move on. So, quick thoughts. Any quick thoughts? Okay, so now coming to, so are we all clear what we are kind of doing in each of this class? Then we'll kind of do a little bit more to understand what we are doing it for the whole academic year. So now I think the most important thing is coming to, we have good number of teachers who have taught this program for one whole year, right? So let's hear from their experiences of what was this 1 year teaching the computer science was all about, right? So maybe all the teachers who have taught this program the last year. So here is where like I want you to participate more, where we kind of reflect on what we have done the last year. So the first thing that I want to know is, what was your biggest challenge the last year? What did you struggle the most? Maybe put it on the chat. Teachers who have taught this program the last year, can you please help me understand what was your biggest challenge the last year? Someone please speak up. Yes. Yes, Rashmi ma'am, you can unmute yourself and then.
Good morning, sir.
Good morning.
This is Rashmi from PICT.
Yes.
When we
Yes.
started off with computer science, Exceed last year, our biggest challenge was time management. Especially after the action, we would be easily able to finish off till the analysis. At times, we used to struggle with HOTS question. I mean, complete the HOTS and the workbook in that stipulated time of 40-minute class. Later on, slowly, we also got the hang of it, and then the lesson plan used to go smoothly.
Got it.
For coding part, yes, when it is for higher, I mean for grade 7, when there is extremely new topic of Python or something like that, where it is too much into coding, where it has been introduced for the first time for the children. Yes, the action part takes a bit more time than planned at times based on the response from the children.
Got it.
Otherwise, for most of the chapters, workbook completion is not that challenging now.
Got it. I think that's great to see, great to hear also. Okay. And anything else, ma'am, that you have faced as a blocker last year, other than this?
The new softwares, especially the installation of new softwares,
Okay.
most of them, I mean, we had received a solution of online thing, which we have implemented with a dummy ID and thing. The only challenge there, I mean, that is possible for Canva and things, but then the only challenge is that extra time that is required to log in of
Got
those
it.
accounts and taking care of like no misuse is happening with the, I mean, we are not able to share the passwords and this with children for an easy login. That has to remain with the educator, and that at times consumes time for login and then ensuring that everything is logged out and then changing the password as the backend admin task which stays.
Got it. Got it. Okay. I think, sure, ma'am. I think we'll just figure out like what is the best way of doing it, and
Yes,
then
thank you,
we'll
sir.
keep you posted. Yeah. Okay.
Yes.
Others, someone who would like to share their experiences of teaching last year? Someone else? I think there are a lot of teachers who have taught this program the last year. So what was the biggest challenge? Anyone else? Okay, fine. So we'll also, or if you're not so comfortable sharing it or talking, just put it on the chat also. That would be good to hear from people who have been using this program for one whole academic year. So all of your feedback will be a lot more useful to us to make the product much more better, to realize its goals, right? So now I think there are a couple of things that because in this academic year, what I have also done is I've also visited a couple of schools wherever that is was kind of possible, right? And this year we would like to do that more. Now, considering that, I think one change that I've generally noticed is the last year kids who have gone through this particular program, there's a change in the way they were kind of thinking about technology, right? So again, going back to the teachers who have taught the whole academic year, what we have taught them a multiple different kind of things. So were there any concepts that was most interesting for your kids? Were there any concepts, were there any kind of things that they have done which was most important for your kids? Anything? Or else at least put it on the chat, please. Anything? So this is what I have heard from a couple of schools that I have interacted at the end of the academic year, the last academic year, right? So one, right? And it is great to see that in our very first year, the program has impacted a lot of kids. And something more fascinating, and then something for someone who I mean, we have built this particular product to ensure that the technology education in this current age is something that the kids learn it the right way. I think of various different concepts. Digital citizenship as an one pillar has really stood quite strongly, right? Where kids were asked talking about what is the right way of using the technology, and especially in the current context of AI and all, talking about ethics of technology and cyber security concepts and all of that. I think this was one of the prominent pillars which actually stood out to a lot of different schools. And do people also agree to it based on your experience of teaching it last year? If you agree to it, please put it on the chat. Yes. So I think digital citizenship as one of the strong pillar has resonated with a lot of kids who have used this program the last year. Then I think the most one more fascinating important thing that we have also heard, and I've also seen a lot of interesting projects that the kids have done, is a lot of interesting projects of games, the kind of games that they have built, or the kind of movies through the filmmaking concepts that they have learned, or the kind of Canva designs for different posters or the 3D models. I got to see a lot of interesting projects from various different schools. So that building of that particular project as a part of this academic program has also resonated with the kids. And especially some kids have loved doing this data analysis through their spreadsheets, and then the others. And some of them were kind of quite eager to build some Scratch Junior games right at lower level grade kids. And I also saw certain good quality websites that the kids have built, especially grade 6, 7, and 8 last year. Right. I think these are the things that we should definitely be looking forward to in the kind of the impact that the program is kind of creating on both kids as well as you as an educator. Right. So now I think what is something that I want to hear from the teachers who have taught is, what positive change did you notice in your kids who have learned through this particular program? What is that you have noticed? Was there any new skill, confidence, or curiosity that they have built, or is there anything that surprised you the most? Someone? Or it would be good if you can put it in the chat as well. All the teachers who have taught the last year, so what did you notice in your kids after going through this program for the whole academic year? Did you notice them developing some certain new skills, confidence, or what is something that really surprised you? The kind of projects that they were building or anything of that sort? Anyone who would like to share? Okay. And then the second thing is, like, as a teacher or an educator who has been teaching this program, so I think what got easier, I think Rashmi ma'am has told, like, she was able to finish things on time. But what is something that was most surprising and challenging for you, or what was the learning for you the last academic year? Someone who would like to share their experiences? Good to hear voices, or even if you're quite not comfortable speaking, put it in the chat. Anyone? In your school, you had science exhibition, students did their own projects. That's good. Ma'am, which school, ma'am? Pavitra, ma'am? Okay, others? Okay, great. Okay. Others? As an educator, did you notice any change the last year after teaching this program for the whole academic year? Okay. So I think quickly what I would like to do is probably there were also based on my interactions with the certain schools, there were some three important things that have come which probably a lot of teachers were kind of struggling yes last year, right? So probably what is our suggestion to those things is something that's here. I think there were three things that teachers have conveyed it to us saying that coding felt hard to come some of these kids, right? Because maybe they are learning this kind of concepts for the very first time, right? So our my suggestion is maybe like for us every week we have a classroom class followed by the lab class. So helping the kids understand the concept well, as in like what is this concept, how are we going to do, which is what we are kind of aiming to do it in our classroom class. So if we are getting that classroom class understanding of the concept well, then I think making them go through the step-by-step coding guide where we help them follow the steps, and then if they are kind of stuck at any other step, providing them the personalized feedback and then the guidance, that will actually ease out a lot of, struggles that the kids will have, especially building a little bit of more complex coding projects, right? Then followed by, I think there were a lot of too many applications is what something the teachers have, right? So the goal here is to not to master every single app, right? But as a teachers, like one of the suggestion that I have is before you teach any of your lab classes, please build that particular project by yourself once, right? So you know what it takes, and you also know your kids well, so you also know where your kids struggle the most. So I think the next class when you're kind of doing that your demo classes, I mean when you are teaching your lab classes, you do a really good job, right? So the idea of the whole of this program is to not to help the kids master every single app, but it is get them to exposure to various different apps and the possibilities of doing the kind of different kind of projects, right? And in order for us to realize that particular goal, I think the only suggestion that I have is before you teach, please follow the instructions and then build the project by yourself, at least one day or couple of days in advance depending on your schedule, so that you can teach it really very well and then fine tune it to what your kids kind of expect, right? And then the third thing that a lot of teachers have brought up is like assessing through the projects, right? Because our whole assessment, I think there was also on the chat that I think people who have been using Exceed for some time, so they know that we have something called as test maker for other subjects. For computer science, we don't have test maker, right? What do we rely on is assessing the kids through creation of the projects. I'll show you like what is this projects, and then the whole project ends with the capstone project, which is a major project that they do at the end. So the whole idea is like I think even the last year, the next subsequent training, the rubrics, what rubrics that we use to assess the kids. So that is something that we will build more concretely so that you're more comfortable assessing the projects through the rubric that we share. And then I think one, we have a strong emphasis on what the kids are able to build through that particular technology, and also at the same time can share their experiences of building that. So the whole idea of taking an idea to the final finished project is what we kind of evaluate the kids on, right? So these are three prominent things that a lot of teachers have brought to my notice. So I think these are few suggestions that I have. Probably you can use that for your upcoming year so that the things will be much more streamlined, right? Now, having said this, what I would like to help you understand is one is what is this whole program about, right? So just let's take this grade 4 as an example, right? Now, when we are saying that every block is nothing but a week. So now what are kids going to learn through the whole academic year? So the whole of grade 2 learns close to around 18 blocks, which means 36 odd sessions, right? So in this 36 odd sessions, now every grade, right? Whenever you're kind of teaching your first initial 5 blocks, so your initial 5 blocks focuses on something called as bridging the learning gaps. Okay. Uh, so what do I mean by that? Now, say for suppose you have your school is using the Exceed Super Teacher program for the very first year, right? The last year they might have learned something in a different way, or you have a kids who have never learned computer science, but they are now sitting in your grade 2, right? So now how do you bring them to the level that you are kind of expecting them for this consecutive year, right? So in that case, the way the program is kind of structured is the very first 5 blocks you take of any grade for that matter, it actually addresses the learning gaps, what the kids might have for that consecutive year, so that they are prepared for what is expected to be done for this academic year. So grade 1 will have the same 5 learning block. I mean, the initial 5 learning block focuses on bridging those learning gaps, similar to till grade 8. So the program is from grade 1 to grade 8, right? So the Exceed program is from grade 1 to grade 8. So every grade, the very first 5 blocks focuses on fixing these learning gaps. Now, what are we teaching here? Here, the block 1 is about helping the kids understand what are computers. Maybe I think I'll just take grade 4 as an example so that you'll understand. So all of those things are getting covered. All right. So if you just see here, grade 4, grade 2 had 18 blocks, grade 2 will have 20 blocks. Right. In this 20 blocks, if you just take the first 5 blocks, right? Again, in grade 4 also, the first 5 blocks focuses on your fixing the learning gaps. Now here, the first block is about helping the kids understand, because this is the very first lesson that you're teaching them. It is about helping them understand what is this technology and how it has evolved, right? Again, it has a classroom lesson followed by a lab lesson, right? Then your second block is about digital footprints. Like our whole computer science program is not just another coding program, but it is a technology education program which gives them an exposure to all the various aspects of technology, right? So coding being a strong pillar, the other strong pillar we have is the digital citizenship. So in this digital citizenship, here it is about learning about the right way of using technology, what are the pros of it, cons of it, and in the world of AI, what is this ethics of technology, how do people use data for various different means, or about how to tackle your cyber crimes, or it is about your fake news, phishing. All of those particular concepts is something that we teach under digital citizenship as a pillar. And here for grade 4, it is something called as a digital footprints. So this is what you teach them, making them follow the 5-step Exceed process. Then when it comes to the lab class, your lab class is always connected to your classroom class in terms of the concept that they have learned, right? So considering that this is a lab class, so here what are kids expected to do is they are expected to design a digital footprint awareness poster. Now they apply whatever that they have learned in their classroom lesson in order to come up with a good design for a digital footprint poster. Again, same like your coding lesson, this also has a step-by-step instruction where we are kind of helping the kids learn to come up with this a good design awareness design of footprint awareness poster, where they learn to use the tool called Paint. So using helping them to learn to use that tool called Paint, we go step by step in making them do this particular project. So by the end of the class, they have a design project where we are teaching them design. In that teaching them design, we are teaching them how to use the tool called Paint. Right. The focus is not just on teaching the tool Paint. It is about teaching them that design, what are the other elements of it. Again, it follows the same step-by-step process to get the project done. Right. Then the way the program is kind of structured is grade 1 to 8, we bucket them into 3 groups. Grade 1 and 2 is one bucket, 3 to 5 is another bucket, 6 to 8 is another bucket. So from grade 1 onwards, kids start to learn to code using block-based coding. So grade 1 and 2 use Scratch Junior, 3 to 5 is Scratch. Then from 6 onwards, we move to text-based programming, where they learn to use Python as a language. Right now, considering that this is grade 4, so the kids in grade 3 have started to learn to code using Scratch. But again, we have a dedicated block, which means we are spending one whole week to get them familiar with Scratch. So the kids who are doing it for the first time, or if they have any learning gaps, they are getting comfortable about this particular program, because they'll use it in good number of blocks in this academic year. Then every block focuses on one concept. Like how you have seen block 4 of grade 2 was focusing on sequencing. Again, if you see here, grade 4, we are again teaching sequencing, because it's a part of the revision blocks, right? Fixing those learning gaps, right? So maybe the kids are learning the concept of sequencing for the very first time. But this is appropriate to the age group of a grade 4 kid. The examples, analogies, the rigors is all pertaining to grade 4. And then they learn the concept, they do an activity related to sequencing, which is again age appropriate to grade 4. Then they move on to learn a new concept called algorithms. They apply the concept to create a project. Then it is about the concept of loop. They apply to create a project using the loop as a concept. So now all of these blocks where they are learning a concept and then they are doing an activity, we call them as something called as a regular block. Right? It is about a classroom class where you're teaching them the concept, followed by a lab class where you're making them apply that particular concept. But in between, we have something called as project blocks also. Project block is nothing but they have learned all of these concepts in silos. So they have learned a sequencing, they created an activity related to sequencing. They learned algorithms, they created a project related to algorithms. But now real world doesn't work like that. No, it is not like just one single concept. So the idea of your project block is to help the kids understand how all these three concepts, which is like sequencing, algorithms, and loops, are all coming together to create a project. So that is what you do as a lab. So here there is no classroom class and a lab class. Whenever you have a project block, which is kind of identified here on your app, it means that both the classes are happening in your lab. And the ideal recommendation is whenever the kids are working on a project, it is good to make them work in pairs. Right? Or even if it is a group, that's great, but please make them work in pairs. At least, right? Then moving on, again, they learn a new concept called events. Then it is about conditionals. Now they have learned these two new concepts, so they create a project, which is about creating a maze game. So they learn how an event and conditionals are coming together to create this or build this maze game. And then we teach them the concept of debugging right from grade 1 onwards. But here, concept of debugging is not like how do you uh, what do you mean is it's not about just fixing the code. It is about helping the kids understand what is this debugging about. It could be about fixing a toy to fixing a error in your math work or anything of that. From there, we kind of build on to fixing the code. So that's the reason, like I would recommend whatever the grade that you're going through, please go through both the content books in prior. So you know what we are teaching, how we are teaching, so that you are well informed. Then we have another pillar which is called data analysis. So here in this data analysis, it is where like we help the kids understand what are the different sources of data. Data comes in various different forms, and then how do you play around with the data, doing some simple data analysis using your spreadsheets and then the other things. That is what we kind of teach under the data analysis pillar. So that is what you get to teach them here. So it is about helping them understand this data, and then it is also about helping them master the use of a tool. Say for suppose, let's take this simple example. So this is a block which is about a project where they collect the data, and then whatever the data that they have collected, they try to analyze this data using a simple bar graph. So this whole classroom class is about collecting the data. Then from the data that they have collected, they'll draw a simple bar graph on pen and paper. Right? So that is what you guide them, which is very similar to what they would do it in a math class. But now when it comes to the lab class, so the same data that they have created, which is on a pen and paper, now what they do is they put it in the spreadsheet. So they learn how a spreadsheet can be used to convert the same data, same bar graph, which they have drawn it on a pen and paper, to what they can do it in the spreadsheet using a bar graph tool, right? Then followed by you have a blog that teaches them about game design. So this here, they have to create a gem catcher game where they understand the basic concepts of game design, where it is about what does a good game need. It needs good rules, goals, or some challenges. And based on this, if you go through the content book, you'll find it more clearer. So the idea is again a project block, spending 2 sessions in the lab to create this gem catcher game. Then it also exposes them to digital art. And then earlier, if you have seen, they are using Paint as a tool for design. So they get exposed to use another tool, Tux Paint. So the idea is not just teaching them what a tool or how to use a tool. That's what we have learned across all the ages. But here it is more focused on how you can use the tool to get some project done. So here, either we are making them use Paint or Tux Paint. The idea is to teach them design, right? And then how you're kind of using a tool to come up with a better design. Likewise, you teach them this cybersecurity concept about cyberbullying, and then they kind of create a comic strip on cyberbullying, again using Tux Paint. Then they also learn about what is this internet and how the internet works. Then followed by your whole academic year ends with something called as a capstone project. right? So the idea of the capstone project is all through the whole academic year, they got exposed to learn variety of different concepts. So now the idea of the whole academic year at the end is to create one major project at the end. Now, as I've told you, project blocks ensure that they are working in pairs, but capstone projects ensure that they are working in groups. So your whole academic year-end assessment is on through your capstone projects, and the continuous assessments that you do in between the coursework is through how the kids would create your project blocks. So that's the reason why I have told you is our assessment of the kids learning is more in terms of the kind of projects that they build. So it not just showcases their knowledge, it also showcases like the way of thinking, the way of building, which is more concrete, and probably that's what the recent policy changes are also recommending too, right? So they create a capstone project at the end. So here the project that they are going to create is about quiz game, right? So first is they understand the quiz game, what it takes. So they define the storyboarding of the quiz game and all that. Then once the storyboarding is done, which like they spend this block 19 all together to come up with one good design. So what are the characters, what question they are using? Maybe if you can go through the block, you'll find more details. So once the idea of the quiz game is all sorted, then the next week is all about executing that, right? So they'll translate that idea to the final finished project. So the whole idea of this project and then the capstone project is to help the kids learn to take this idea that what they have in mind, how do you structure it, how do you plan it, how do you execute it, if you are kind of finding the bugs, how do you fix it, so that you are finally able to create a real project. So that is what the whole idea of the program is all about, right? How do you empower kids to build some real projects where they take the journey from an idea to the final finished project, right? So that is what which they concretely learn by creating this capstone project, right? And we don't end with just creating a project. So our recommendation is at the end of the capstone project, you should have one showcase session for every grade or depending on multiple grades at the end of the academic year, where kids would come and showcase the projects. They'll share their experiences of what they have built, why they have built, what they have learned. So we are not just focusing on kids who can build, we are also building kids who can speak comfortably what they have built and then show a rationale of what they are thinking, so they can communicate about technology in a much more simpler, easier way, right? So this is the intent on which the whole computer science program has been built. So would be great to hear some new teachers who are going to teach this academic year, as in like what do you think about this program, and are you excited in teaching this program for the coming academic year? Just put it in the chat, please. And it's also the time for us to wind the session. It would be great to hear a few voices. If not, at least put it on the chat. On a scale of 1 to 10, how many of you are excited teaching this program the coming academic year? Just put it on the chat, please. On a scale of 1 to 10, 1 being like not so excited, 10 being like great, I'm looking forward to it. Others, let's keep rolling faster. 9.6, 9, 10, great. Okay. Alka ma'am, maybe the next time when you come to the training, I think maybe your number will be higher than 8. Great. I'll look forward to that. Others, please put it in the chat. So I think what is it is post this training session, we'll also share with you a couple of demo videos. Maybe I think you can look through those demo videos of a classroom class followed by a lab class. So you get a more fairer understanding of how the classes needs to be executed. And if you have also another thing that we would like to share is we'll share with you this doc. I think few things based on our last year experience. So I think system requirements, these are few things that we would recommend. I think mostly what we need is if you have a processor more than i3, that would be great. Yeah. Quick question is the students who are new to coding any device. Yeah. So like especially in the earlier grades, your first five blocks will actually help them get comfortable with the usage of technology. So you're spending like roughly around 5 weeks to get them exposed to building something more real. So I think those first five blocks should be giving them a good platform to start being comfortable more with the technology, right? Then from a RAM perspective, at least if we have a 4 GB RAM, that would be great. Operating system perspective, better than, I mean, Windows 11 or later, right? Then, but what is more important is because most of these softwares that we are going to use as a part of this program are all free open source softwares. So it would be great if you have a stable internet connection, right? I think that will be of lot of advantage when you're actually teaching, especially in the lab classes, right? Not in your classroom classes. And then for all the, this is also something that will roll out where here in on this doc, you'll be able to see what are all the softwares. And then as I've told you, these are all mostly free open source softwares. So you'll be able to access most of this through the links that we kind of provide. Right. And then if you have any questions, feel free to reach out to us at contact@exceededucation.com. We'll look into it and then we'll get back to you as quickly as possible. Right. And some of it we'll kind of share with you post this training. I think the most important thing will be you will get your demo classes of how a classroom lesson needs to be taught and how a lab lesson, so that you have a more fairer understanding. And we would like to hear more feedback from teachers who are teaching this program for the first time. And if you have any struggle, please feel free to reach out to us at contact@exceededucation.com. Right. And we rely on you, considering that whatever that the intent with which the program has been built. So it's you who are kind of actually putting the program into action in your classrooms and then impacting the kids in the way they kind of learn about technology, use technology, or how to, or the kind of things that they can create with the technology. So you are a very important stakeholder who are kind of shaping the kids' technology connection. So we rely on you for effective implementation of the program, and you can always feel free to reach out to us for ensuring that you are more comfortable delivering the program for the way it was kind of intended to, right? And maybe on a quick chat, if you can just put in how useful was this session for you, and is there anything that you are looking forward to in the next session? If you can just put it on the chat, that will be great. How useful was this session for you? And also, like, if there is anything else that you would like to know, or because we also do another training session, and we also do this training session a couple of more times for other teachers. If you have missed, you can again join. And for people who want to revisit this training, this will be live on our YouTube for next couple of days. So you can definitely go back and then watch it, make notes, all that, right? And anyone else who would like to share any feedback on, okay, what more, probably something that you are expecting but was not covered? Okay, great. And I mean, I wish you all a great luck and look forward to getting this program into the real classrooms where kids are kind of doing a great projects and you are also enjoying teaching this particular program in the class. So we look forward to the next training session, and good luck for everyone. And then we rely on you for the program success. Thank you so much.